Hi, I'm Sebastian. My metric number is U1810133B. Now I'll be going through the proposed ER diagram for MHL. The ERD which we have devised can be seen here. So we have we have the following entities: user, follower, activity, personal best, weekly leaderboard, club, and challenge. In addition, we created a few associative entities, namely user challenge, user club, kudo, comment, and user weekly board, so that we can decompose the M&N relationship between their respective entities to ensure that the ERD is in the 3NF. In each of the table, we have indicated the data type for each attribute so that each field can be keyed in properly. In creating the ERD, we made the following assumption. First, one user can have 0 or many followers. A user cannot be followed by the same user twice. Next, one user can join 0 or more challenges. A challenge must be joined by one or more users. Next, one user can join 0 or many clubs. A club must be joined by one or more user. Next, one user can be in 0 or many weekly leaderboard. Each club can have 0 to many weekly leaderboards. Weekly leaderboard would be generated as long as a member of the club exercises. The weekly leaderboard ranks the total distance covered by each member within the week from the greatest to the least. Next, one user can perform 0 or more activities, but an activity can only be performed by one and only one user. One user is able to give 0 or more kudos, however, one kudo belongs to one and only one user. This is the same. An activity can receive 0 to many kudos, however, each kudo must belong to one and only one activity. Next, a user can give 0 or more comments, however, a comment can only be given by one and only one user. Next, one activity can receive 0 to many comments, however, each comment given must belong to one and only one activity. Lastly, personal best records the best pace of each user. Each type of activity can only have at most one personal best, and each personal best records belongs to one and only one activity. This next slide shows the relationship between each entity in the third normal form. Each field inside the square bracket is an attribute of the entity. Both attributes represent the primary key, and the underlying attributes indicate that the attribute is a foreign key from another entity. So for example, in the challenge table, the challenge ID is the primary key. For the follower table, the follower ID and the user ID is the primary key for this particular entity. This is also known as a composite primary key, as the user ID and follower ID column must be used to identify each row. At the same time, these two keys are foreign keys that is derived from the user table. So these two keys serves a dual function of being a primary and foreign key at the same time. Next, I'll be going through some of the inconsistency between relational data model and the non-relational data model. Firstly, there is a difference in structure. In the relational data model, our database has the following tables and columns. In a non-relational database, our database has the following collections and fields. Project mutual following is used to solve query number 4. Project user following female male queries solves queries number 2 and 3, while project activeness is used to solve majority of the queries. Next, there's a difference between the data loaded in SQL and NoSQL. In the non-relational data model, the following table information have not been reflected: challenge, club, comment, weekly leaderboard, personal best, user club, user weekly leaderboard, and user challenge. That information is not relevant as the queries do not look up to them.
Hi, my name is Javier, and my metric number is U1710795B. So I'll be doing the queries for SQL for questions 1, 2, 3, 6, and 10. Kang will be doing the queries for 4 and 8 for NoSQL, and Queenie will be doing the queries for questions 5, 7, 8 for NoSQL. So in essence, we have covered every single question for this presentation. Right, so for the first question, we have to generate a list of users who are more than or equals to 21 years old, and we'll be using the users table. What we'll query out is for the user ID, username, gender, and age. So what I have to do is to set a condition equals male and the age more than or equals to 21. We query it out and we get these three outputs. So that's for the first query. So for the second question, we have to generate a list of male users who are following more female users than male users. So what we do first is to generate out the list of user IDs and their genders, as well as their followers ID, that means the people who are following them, right? Then the next thing we do is to count out for each user ID their gender, as well as who they are following, right? So you can see over here that user ID 2 is male, follows 2 male and 3 female, right? So the next step, this is the final step, what we have to do is to filter out for those users with male gender, and they have to have the female count higher than the male count, right? Because and that's question 2. And for the output, we'll have user ID 1, 2, they are male, and they do indeed follow more females than males. So for question 3, the question requires us to generate a list of female users who are followed by only male users, right? So for the first part, what we do is to generate out the user ID, and we get their male counts and female counts for the people who are following them, right? So the next step, what we do is to filter out for those users who have female count equals to 0 and a male count more than 0, because what we want is a list of female users who are followed by only male users, which means female users should be 0 and male users should be more than 0. So we have user IDs 3, 5, 6, and then the final step is to filter out for their genders to be female, right? So you can see over here, female, and we have users 5 and 6 for this output. So for question 6, what we have to do is to so the question states, based on the above activeness insight, which is from part 5, what I have to do is to generate age-based activeness insight, which is to filter out their age below 21 years old, between 21 and 35, between 35 and 50, and finally above 50 for users who have exercised less than 30 minutes, as well as include the activeness insight for, which is for the users less than 30 minutes per week, between 30 to 60 minutes per week, between 60 and 120, and finally more than 120 minutes, right? So what we do first is to generate out the user ID as well as the week number, and the week exercise time is basically the sum of the total activity duration for that particular week. So if you look over here, the output for user ID 1, the second week, he has done a total of 140 minutes of exercise. For week number 7, he did a total of 1,914 minutes of exercise, right? So that's the first step. For the second step, what we have to do is to count the number of weeks there's exercise. So previously realized that user ID 1 exercised in week 2 and week 7. So what this means is that he has exercised for 2 weeks, and we sum up the total time, right? And this is the output. So for every user, there is an output of weeks exercise and total time. Then the next step will be to divide by the sum of the weeks exercise, the total time, by the number of weeks exercise. So we divide it, we get the average time, and then we do a case when to filter into the bucket. So basically 26 minutes will be less than 30 minutes of exercise, and then we repeat this for every single output. And based on this, the last step will be to filter out their age, right? So we look up to the user ID's age, and then what we do is we do the bucketing for their age group as well. So you can see over here, user ID 4 below 21 years old, user ID 7 is between 35 and 50 years old. So that is for question 6. So finally for question 10, what I have to do is to conduct social comparison analysis, which is list out for each user, list out his or her weekly average activity distance and weekly average activity duration, and then additionally we have to compute the weekly averages for his social network, okay, which is those that are followed by the user. So the first step would be to generate out the average time and average distance for each user for each week, okay. The next step will be to generate out their so let's basically for user ID 2 we have to generate out their following ID, right? So user ID 2 follows user ID 1, okay. And the next step would be to join this together, and which is also the final step. We'll join those two tables together, and then what we'll get is user ID 1 with the average timing and average distance, and then and user ID 1 is following user ID 6, and this is the average time and average distance for user ID 6, right? So this is the output, right? So now Queenie will go through for NoSQL.
Hi, I'm Queenie and my machine number is U1640612G. So now I'll be presenting question 5, 7 and 9 for the NoSQL queries. For all the 3 questions, I'll be using the project_activeness JSON file. For question 5, we want to generate the activeness insight. That is the list of users who have exercised less than 30 minutes, between 30 and 60 minutes, between 60 and 120 minutes, and more than 120 minutes per week. To start, we use the aggregate function, and then we group according to the user ID, which is within this group operator, we make use of the add to set operator to create the unique week variable to find out which weeks each user have an activity, and then we get the size of this unique week variable to see how many weeks each user have exercised. We then pass this value on to the variable week_exercised. We also create a variable total_duration within the group function to get the total duration of all the activities for every user. Then we create another variable average_exercise_duration where by dividing the total duration over the week_exercised so that we can get the average duration that each user have exercised per week. After that, we create another variable activity_insight to group the users according to the criteria set by the question. We make use of the switch case function to group the users accordingly. For instance, for those that have exercised between 30 and 60 minutes, we create the case and also the AND operator to obtain 2 of the logical statements, which is greater than equals to 30 minutes and less than 60. Then we use the then operator to print out the desired string. Finally, we use the project operator to obtain the desired output, which is the user ID and the activeness group that it is in. So for instance, after running the code, we see that user 4 exercises between 30 to 60 minutes per week. Next, for question 7, in addition to the activeness insight, we want the age group and the gender of the user. The code for this is similar to that for question 5. The difference is that in the group function, we need to create 2 additional arrays for age and gender. We then create the age_group variable using the we want the age group and the gender of the user. So this is very similar to question 5. The difference is that in the group function, we need to create 2 additional arrays for age and gender. We then create the age_group variable using the switch case function that is similar to the activeness insight. However, for the gender, we make use of the reduce operator to sieve out the user's gender from the gender array. We then use the project operator to obtain the desired output. So from the output, we can see that user 2 is a male that is below 21 years old and exercises more than 120 minutes per week. Lastly, for question 9, we want to compute the monthly social networks. That is, for each user, we want the list of his followers that have given them greater than equals to 5 kudos for each month's activities. For this question, we also make use of aggregate function. Since the kudo given ID is listed as an array in each document, we unwind this field. We then make use of the group operator to group multiple fields, namely the user ID, the kudo giver ID, and the week number, to create the user count total, to count the number of kudos each follower have given them for each month. We then use the match operator to find the user_count_total that satisfy the requirement of greater than equals to 5 kudos to get the desired output. So from the output, we can see that user 7 gives 6 kudos to user 1 in month 2 alone.
Hi, my name is Kang and my matrix number is U1810804L. Now I'll be going through queries 4, 8, and as well as concluding today's presentation. So, to start off with query 4, the question goes, we need to generate a list of users who are following each other mutually. So first we'll be using the find function, and following which we'll be using the key value pair to go and find what the question wants. So for this, name1 following name2 as well as name2 underscore following underscore name1 are the keys, while yes is the value. So we'll be finding for users who have both mutually follow each other and is given below. So Javier and Javier are following each other mutually, and as well as Kang and Justice Go are following each other mutually. So this is question 4. And moving on to question 8. The question asks to generate a list of users who have received more than 5 kudos on average for each activity. So for this, we'll be using the aggregate function, and first by grouping the collection via first the user ID, and secondly via average kudo. However, average kudo is a derived function from taking the average of all the sizes of kudo giver ID. Kudo giver ID being the people who give the kudos to the user ID. So basically we'll be finding the size of the array, after that taking an average of the activities to get you the average kudo. And after which we'll be using this derived function of average kudo by matching it to ensure that it's greater or equals to 5. And by running the whole entire function, we find that user ID 2 has an average kudo of more than 6. So that is the end of question 8. So all in all, we'll be recommending NoSQL as a database for MHL to adopt. And the reasons are as given. First, fault tolerance. Secondly, data manipulation. Third, cheaper to scale. And fourth is speed. So, moving on to the first reason, fault tolerance, because we see that in the long run, there will be multiple users joining this application at different timings, and the multiple users will run and log at various timings. Corresponding records will eventually be seen on the NoSQL database as compared to SQL, as compared to relational database, which might not be able to support this. Secondly, on data manipulation, data can be easily inserted on the NoSQL platform, as it does not have to be normalized as compared to a relational database. So thirdly, it is cheaper to scale, because NoSQL scales by adding commodity hardware, for example more servers, in order to scale more efficiently. So lastly is speed, and the reason is this is because NoSQL is faster because it stores data in flat collections, making reading and writing faster and easier. And with that, we have come to the end of today's presentation, and thank you, Professor.